ISM5021 Final Competition Group 10. Our team members are David Alabed, Joseph Fryer, Colton Mattel, Jeffrey Mayhann, and Christopher Tablak. Convolutional neural network is a breakthrough new technology that is an extremely sophisticated computer algorithm which allows computers to accomplish things that were impossible just a few years ago. CNN allows computers to see visual information such as photographs, images, handwriting, and videos. This technology is also the backbone of the most promising versions of artificial intelligence. Truly, CNN is influencing technological breakthrough across many facets of our daily lives. For example, CNN is changing the tools that you use every day, such as YouTube, Facebook, and Instagram. Not only that, but it has great implications in the field of security, both private and public. In fact, CNN's gate recognition abilities alone make it a valuable tool for national security. Further, CNN is unlocking handwritten archived documents from around the world. By understanding written language, it provides a tool to decode and understand thousands of years of writings, which until now has been impossible due to the amount of labor required to do it. So how does it work? We're glad you asked. Convolutional neural networks are networks of computer neurons that are arranged together in layers, allowing computers to process visual images and interpret what they are seeing. This is done by breaking up the image into pixels and associating each pixel with a neuron. This first layer of neurons is called the convolutional layer. In mathematics, a convolution is a mathematical operation on two functions to produce a third function, which is a modified version of the first two. Each neuron in the first, or convolutional layer, is then associated with a second layer of neurons called the hidden layer. A CNN may have multiple hidden layers, and for that matter is generally made up of multiple sets of convolutional and hidden layers. As each pixel in the convolutional layer picks up a particular value from the grayscale of the image, it activates or fires. This is analogous to the neurons in your brain, which fire when they're activated by a particular stimulus. Like those neurons, this activation causes the neurons in the CNN to also fire, ultimately allowing the CNN to recognize the object being seen. When a CNN analyzes an image, the first layer of neurons picks up the value on the grayscale that matches each pixel. This neuron will only fire if the value is above a certain threshold. This information is then passed to the second and subsequent pooling layers, which also fire if multiple pixels send the appropriate signals. These pooling layers add weights to their output to communicate variances of shade from one pixel to the next. These weights can be adjusted to fine-tune the accuracy of the network. Finally, these pooling layers send their signal to the fully connected layer, which is where the network makes its final assessment about the content of the image. One of the most useful features it recognizes are edges, or the distinct breaks between dark lines and lighter colored areas. For example, eyebrows, nostrils, and lips provide such stark contrast on a person's face. By finding these edges, the CNN can begin to piece together that the image is a face. Then by comparing the distance between key points on the face, it can recognize specific faces. Since the placement of eyes, nose, and lips, coupled with the width and length of the face, are nearly as distinct as a person's fingerprint. This technology is one of the ways that social media tools know how to insert tags below the images of faces in the photos that are posted. This same technique is used to identify many other items, such as handwriting symbols, cars, animals, landscapes, and human movement. In each of these, the network is not looking at the image as a whole, but as the sum of many tiny pixels. More complicated images require more layers in the network. Of course, this convolution requires an immense amount of computing power, which was unfathomable when this technology was first theorized by neurophysiologist David Hubel and Torsten Weisel in the 1950s. But exponential growth in processing speeds has brought their theory into reality. When CNNs are first built, their accuracy tends to be quite poor. Therefore, they require training, which involves the analysis of thousands or even millions of inputs, referred to as training data. This data lets the network know if it achieved the correct outcome, and the CNN automatically adjusts the weights associated with each neuron until it has achieved the optimal amount of accuracy. In this way, the network is actually learning, which is why CNNs are one of the greatest advances in the science of artificial intelligence. This same tool has now been applied to many other areas where machine learning is desired. One of the greatest successes has been in the field of gameplay. CNNs have now been successfully created, which have trained themselves to play some of the most complicated games known to man and are beating world champions.
A computer program beat a human brain at the ancient Chinese board game of Go. The final score 4-1, a triumph for artificial intelligence equipped with human intuition.
The victory of a program over a human in the ancient board game Go has sparked intrigue and, in some cases, concern.
I think maybe the game ended.
No, I don't think so, because it looks like he is still counting.
No, I think he resigned.
Wow, I think you're right. Wow. Wow.
This was the moment a computer called AlphaGo beat a master of the ancient Chinese game Go. It's not the first time a grandmaster's been humbled by a machine. But what makes AlphaGo different is that it's the first demonstration that machines can truly learn and think in a human way. AlphaGo's victory shocked experts in the artificial intelligence community. Many thought such an event was at least a decade away.
AlphaGo shows that machines can really learn. How so? Well, instead of using brute force to calculate all the moves it could make like previous AIs, AlphaGo used reinforcement learning and neural networks to mimic the learning process of a human brain. Keep in mind that the ancient Chinese game Go has as many more possible moves than chess as there are atoms in the entire universe. So there's no way of just calculating every possible move on the board. That's practically impossible. For this reason, Go is the holy grail of AI, and learning to do such a task from scratch is a huge feat. Further to this, DeepMind's creators say that the algorithm can learn many more things without alteration or guidance. In other words, the AI is general purpose.
We always used to talk about, well, if we could eventually crack Go and have a program that could beat the world champion, then we must have invented some generic, general purpose algorithm. So maybe we're on the cusp of all of that. If you ask a great Go player why they played a particular move, sometimes they'll just tell you it felt right. So the one way you can think of it is that Go is a much more intuitive game, whereas chess is a much more logic-based game.
Okay, so how does this all work? The AI from DeepMind uses a technique called deep reinforcement learning, which makes it very different from other AIs, such as IBM's Watson or the primitive Siri or Google Now. The AIs just mentioned were only developed for a predefined purpose and only function within their scope. DeepMind claims that their system is not pre-programmed and it learns from experience using only raw pixels as data input.
So the way we start off training AlphaGo is by showing it 100,000 games that strong amateurs have played that we've downloaded from the internet. And we first initially get AlphaGo to mimic the human player. But of course, ultimately, we would like AlphaGo to be stronger than human amateurs and compete with the top professionals. So the way we do that is, after we take that first version that's learnt to mimic human play, we then allow it to play itself 30 million times on our servers, and using reinforcement learning, the system learns to improve itself incrementally through it avoiding its errors and increasing and improving its win rate against older versions of itself. And after all these games, then you end up with a new version that can beat the old version, the original version, around 80-90% of the time.
Technically, the reinforcement that DeepMind uses is model-free, meaning that it doesn't need a structure or set of rules to learn. According to MIT's take on the Google algorithm, the neural network, in theory, should be able to access an external memory in a manner that mimics the short-term memory of the human brain. In a way, it almost seems like our brain's design might be the most efficient way for the creation of local intelligence. Who would have guessed? So that's all good. What about this general purpose term? What does that actually mean? Well, because the machine learns from raw experience and data, it can perform well across a wide variety of tasks, straight out of the box. Okay, so that's enough talk. Let's watch the system in action, learning how to play Breakout. And remember, the machine didn't have any foreknowledge as to what task it was going to complete. It had to figure out how to do everything only from its own experience.
Is the machine before training. So this is literally the first time the machine has ever seen this data stream, and it's controlling the green rocket here, and you can see it's losing its 3 lives immediately. So it's basically terrible at the game, as you would expect. Now after training, this is like overnight, we leave it playing the game overnight on a normal computer, so for about 8 hours. You come back in the morning and now it's superhuman level. So now the machine can play Space Invaders better than any human can. It's modeled the game world so well, it knows where the Space Invaders will be ahead of time. So as the Space Invaders speed up, when you get less of them on the screen, it fires the final shot as a kind of predictive shot of where the final Space Invader will be in a few seconds.
However, this technology is not without risks. There are obvious ethical problems. The job losses which will occur when machines replace people in such fields as accounting, medicine, finance, and other knowledge industries. Privacy concerns, as bad actors will be able to use these networks to invade privacy to an ever-increasing extent. Inequality concerns, as it will be necessary to divide up the wealth created by machines, who will benefit and who will lose. And then there are concerns over unintended consequences, or evil genies. After all, once a computer is able to learn on its own, how can we know for certain what conclusions it will draw, or what it will do with the knowledge it has gained? For this reason alone, some of the greatest thinkers of our time are wary of machine learning. Both Elon Musk and Stephen Hawking have publicly stated that AI has the potential to be dangerous, especially as computers become increasingly more autonomous. Since CNNs have been demonstrated to learn completely on their own, such as with the Space Invaders game we saw earlier, it is plausible that they will teach themselves other things. As this happens, their ability to learn exponentially will outstrip man's own linear ability to progress. As such, it is reasonable to expect computer learning to fundamentally change the world in a short amount of time. Elon Musk predicts that machine learning will likely result in most jobs in the future being performed by machines rather than humans, requiring governments to pay workers to stay at home. Stephen Hawking predicts the possibility of an even darker outcome, stating that, in his words, the full development of artificial intelligence could spell the end of the human race. Images such as Skynet come to mind with such predictions. There is no way to be certain how artificial intelligence will ultimately impact the world. However, it is very certain that AI is a powerful tool that is here to stay. As technologies such as CNNs become more capable, they will be used for an increasing number of tasks. In the short term at least, this is a very promising technology.